Okay, so on to the main event. Yesterday we had Jason talking about LF Edge. As you saw, they have a lot of projects that are in the works and in different levels of maturity. One of them is Project Eve. Project Eve is the primary contributor is Zedata, and Roman is one of the co-founders of Zedata. And Aaron is with LF Edge. So Aaron, you're going to see a lot of because he's helping me also put together the meetups and identify which projects to come up. So if you have questions, Aaron's a good resource to get to about LF Edge in general. At least he has been for me. So I'm sure he doesn't mind me giving out his his details to for people to connect with. But so maybe we can start with Roman and Aaron. If you want to introduce yourselves, where you are, how'd you get here, and then take it from there. Roman, can I go first?
Yeah, sure. Yeah, absolutely. Hello, everyone. So my name is Roman, and it's really good to be here. It's virtual, but this is all we can do, these days. So I'll take it. Yeah, I mean, I've been sort of in this space for quite some time. Started the company about 4 years ago with a few friends of mine, and we've been trying to basically disrupt what's now known as edge computing. For all that time. So built a software project that got donated to Linux Foundation. This is the project we will be talking about today. We're building, drop me a note. We are still hiring.
Bandwidth. Go ahead.
Yeah, absolutely. So, like, if anything excites you, drop by our open source Slack channel or send me a note. And if you are excited to the point where you would rather join us, that's also an option. So that's me.
Cool, Aaron.
Yeah, hi. My name is Aaron Williams. My title is I'm the dev advocate or community manager for all of the LF Edge projects. I think we're at 9 now. Eve is one of the main contributors. I actually came from Zedata, so it's actually one of the projects I know the best. Not that I can't play favorites, but and so if you have, as Hans said, we're gonna be setting up a couple more of these around some of the other projects. A lot of the other ones, including this one, we might be able to do a deeper dive if people are interested. Just how it actually really works underneath the hood, or some of the other projects are bigger, such as EdgeX. So maybe you have interest in how they call APIs or how do they handle this or that. So hopefully we can do a number of these. I'm currently out of the Bay Area. I'm in the East Bay of that. So, maybe sometime we could actually do some meetups in person somewhere here in the Bay Area, since you guys have so many people throughout the country, but we'll have to wait for that. So I'm assuming that you can see this big orange Zedata, right? Okay, perfect. So that's me. You have questions about any of the projects, whatnot, you want to learn more about it, please let me know. And we'll help you guys out of point you in the right direction, and then see where we can go from there.
Cool.
All right, so I'm gonna, hopefully this isn't exactly what Jason covered yesterday, but we'll kind of go through this. So kind of the idea here is that edge computing as kind of a cloud native to the IoT world. And what we mean by that is edge gateways. These are the kind of these small devices, I mean, relatively small when you compare them to servers, giant when you compare them to probably the first computer you ever worked on, are all over the place. I mean, this picture over here, this is in a semi truck, the same machine is out on out on a farm, and it's communicating with the farm equipment. And this is literally on top of a wind turbine. Um, and so edge is just everywhere. And when we talk edge in this thing, we'll go through kind of like what does edge mean to people. But to Eve, it is really out there, out on the wedge. So how do you handle this? I mean, when we have all of these different devices um, and things out there, and what does that mean? How many different types of compute devices that are out there in the world? How do you survive through this? And basically, it's the Linux Foundation, and especially for us as LF Edge, is about the way that you can survive all of this. And I'll get into some more detail about this. One of the biggest things that we've run into is describing what the edge is. And the edge is, to somebody, it's obvious to everybody, but everybody's obvious answer is not the same. So what we did within LF Edge through one of our projects called State of the Edge is really try to write out a white paper and kind of define this. So I think we can all agree that, centralized data centers are not the edge. These are giant things, Amazon, where all that stuff is stored. But to telcos, they really think of the edge being that cell tower, especially now as they go and start pushing 5G. If you're a device manufacturer, or especially that, the edge really moves down the just way down to, these are those Dell boxes that you saw in all the pictures before. But down here, I mean, this could be in the home environment. This could be a Raspberry Pi. The other is the Raspberry Pi could be down here. Maybe this is something as small as, an Arduino or any of the devices down here. So what's really defines this stuff is these are really constrained, both by power, by memory, processing, things like that. So, and then this is kind of just that. It's just how we all contribute to it, or how each level, the telcos versus the device manufacturers, kind of see the world. So, and I want to kind of focus more down here for this talk. And this is, so as you can see down here, we keep using the same template, so that way I give you a chance to actually read some of these. But this is way down there. This is embedded systems, and these, like I said, these are just entirely can be very, very small, but it really depends on the layout. And so let me just go quick, one last thing up to kind of the top level of what LF Edge is. So we have this down here is that kind of same, where things are located. This part right in here, it's the same service provider edge and user edge, but it kind of puts in where our projects are. So you have Fledge and EdgeX Foundry. These are things that run on the systems themselves, and allow you to kind of, it's a set of APIs, allows you to get that interoperability as it goes through. Where Betel is a little bit higher up this, because this allows you to, it helps you communicate with the cloud, and get you, from the various clouds. This is done by Baidu, so it has a lot of information, just to help you get going through that. Eve, which is right here, this is basically the OS, and Roman will go into a lot of detail for that, and what does that mean as an OS, or and how it's used. Now, Home Edge is another one of our projects, and it is actually probably the simplest one to understand. It helps you communicate between devices at home. So that's where they focus on versus EdgeX and Fledge, much more focus on normal commercial type instances. And then we have one more, our two, what we call level 3 projects are EdgeX, which is by far our largest one, is Arcano, and this is a set of blueprints. So it's basically a set of things that you can follow to build things out. They are heavily focused on telco because that's just where they come from. So the idea is if you wanted to build something out, some type of stack out there, at a cell tower or something like that, this would allow you to go and build that. You could follow their instructions and whatnot. Now, with a project that between Eve and Fledge, we're writing out our own one for the industrial IoT world. So we're writing out our own blueprint, and this is to kind of push them into a little bit more broader scope of what IoT is in this world. All right, this very confusing thing, I'll just hang on for a second, let you kind of digest all the little icons. But this is kind of what the Linux Foundation really is going for. It's trying to give, enterprises, SMBs, all of these guys out here who trying to bring together open source to them. And what that allows them to do is build out the parts that they need, but hopefully somebody else is next to them building out other parts. And this is, the motto of open source. No one can build out everything. Once you do that, then you're now locked into that system. Open source allows you, and it could be your competitors or somebody completely different, and both of you push the code out into the repos, and then boom, and now the whole system is better. Also allows for security, code review. Since everything is open, everybody gets to see it. There's no secret code, so hopefully that will make the code more secure, or at least show you where the flaws are, so people can open that up. Kind of the giant projects that are under LF. Well, first of all, it's Linux itself, and that is done that. But Kubernetes, OpenStack, ONAP, and whatnot. So we also kind of work with a lot of the nice thing about being with LF is that we work with the standard organizations around the world to kind of keep this going. And so kind of following up on that, one of the big things that for LF Edge is kind of this why. Why do you do it? Why do you exist? Most of, I worked for, in the IoT world, I don't know, going on now about 10 years. I worked for a very large German software company. And one of the toughest things to figure out was this kind of where our software, where our special sauce really existed. Versus, did we want to write, things that go on every single device, so that way it could communicate up to our cloud? Did we just want to focus on, this top part here and whatnot? As we talked to customers, and it became very prevalent through actually most of the companies I've ever worked for, is they did not want to be locked in to this. They did not want this siloed thing. I'm not knocking anybody, but the customers wanted to be able to come up here and then go to here or go over to here. They never wanted to be that locked in just for that. Not only that, the devices down, especially down on the shop floor, these could be 10, 20, 30 years old. Various states, various ways of communicating. They might just go to a historian that's local. It might be something brand new and kicking up to the cloud. But always so even if you had a nice green field with all brand new equipment, the question becomes, how much are you sending up here? Some of these machines, if you think of a factory floor, they're kicking out data at what, 6,000 hertz, so 6,000 times a second. And they might need real time. And what I mean by real time is, 6,000 hertz. You don't want your car to be sending stuff off to, to the cloud to come back to turn on your, to stop or, run the brakes or to turn left or anything like that. You can't rely on that. So, there might be something over here just to kind of get that going. So anyways, you kind of, everybody, if you're in the IoT world, you kind of understand that part. But the difference here is what LF Edge does is it allows you to kind of, all the companies that are involved in it, both from a consumer side and from producing it, allows you to build up on everybody else. This is the plumbing part. No one company can do it, and if you do your one part for your one industry on your one machine, then you have to go and do that same thing for the next machine, and then you end up back into the this silo. You're very locked in. You can't add in another one. But with LF Edge, you have that community that's coming in. They're building up this, and then what you do as your as a commercial company, you can't just give away everything for free. You compete up here on the services. So wherever this cloud goes, or out here, you're calling into stuff. Somewhere you're adding, you're doing a value add to it. Versus, I control everything, and then 5 years from now, if you're not happy with this company or a rule changes, maybe they don't have a cloud in your company, in your country. And your government changes the rules on you, suddenly now you're locked. This allows you, going through LF Edge and our projects, allows you to kind of hedge against that, basically. But it also gives you that advantage of the community coming together, building it out. Also, by working with this, it also allows you to see what's coming up. It allows your company to see what's coming up and how you can change for that. All right, and now I'm going to hand this over to Roman. Just let me know when you want me to click.
Awesome. Thank you so much for setting up the stage. So yeah, Aaron was talking about sort of this big view of all the different things that you kind of need to keep in mind. So let's actually take a smaller view now on the smaller devices. What is our ideal experience of basically having an operating system, middleware, some of the business logic running on those devices. So I would like to actually start this presentation by kind of putting a thesis out there, and let's see if you all agree with me. And if you don't, please jump on live chat. It's much more fun to disagree on a live chat. But here's my thesis. What's unique about Edge, and that's actually why a lot of the approaches that are trying to shoehorn Edge into some of the existing technology fail. What's unique about it is that it is actually a combination of two very different views into the computing and how computing needs to be done. So on one hand, like Aaron was saying, Edge is actually a lot like servers, right? All of these little machines, they're not really even so little anymore, right? My joke is that Raspberry Pi is basically a micro supercomputer at this point, right? It has 8 gigabytes of RAM, right? It's like, I, at some point, used to dream about having 8 gigabytes of RAM in my server. Now I actually have it in Raspberry Pi 4. So a lot of the qualities of those machines are actually exactly like servers, right? And yet, those machines are super mobile. They're mobile as your cell phone. And what I mean by that is, they actually don't enjoy the luxury of being housed in a protected data center. They don't enjoy the luxury of having a dedicated network. They basically roam all the time. So again, that picture that Aaron was showing you, one of those machines bolted on a truck, it literally is like your cell phone. It's just a little bit bigger, but other than that, it basically has all the same properties. So what's really unique about Edge is that you kind of need to solve for these, challenges, right? And half of them, or 30% at least, come from the mobile industry, and the rest comes from the traditional server industry. So what are the challenges? So let me actually quickly recap. First of all, you're essentially dealing with, just like on mobile, you're dealing with diversity of hardware and the applications. Again, we are expecting nowadays to basically have just about anything available to us as a mobile app. And the kind of requirements that that puts on the hardware, the software when it comes to operating system, are actually very big and interesting, right? Same deal when it comes to hardware. We expect our Android to basically be available on just like about any handset, or about any mobile platform, entertainment or otherwise, that comes out of big manufacturing facilities out of Asia, and which is kind of expected all to work. And if you think about it, Android was that magic glue that basically completely decoupled hardware manufacturers from the software manufacturers. And we will keep coming back to this Android analogy more and more. The other one, though, is scale and automation. So all of these devices on the edge are geographically distributed. And you cannot really maintain them the same way that you maintain servers in a data center, because even getting physical access to them can be challenging at times, right? Some of them can be bolted on top of a wind turbine. So every time you need to reboot it, you basically have to climb up and climb down, and that's not fun. And finally, and that's actually I think is the biggest takeaway from the mobile industry, is the security implications. Because today, I would say that mobile people are probably the closest to really take security super seriously. Because again, the phones that we have don't actually have the nice property of being protected by various firewalls and whatnot. We can leave our phones in a in a bar, right? We expect them to be stolen from time to time, but we also expect the content, the sort of the software, the IP, that's in there, to not be available just to any attacker. So all of that in mind sort of prompts that we need a different approach when it comes to user edge, this type of convergence between mobile and server computing, and that's in effect what Eve is. So next slide, please. So let's actually skip this because we don't really have much time. So there's like some nice animation, but let me just focus on my favorite aspect, which is security. And security on the edge is all about user access. So we all basically wake up to news on Twitter and otherwise of yet another botnet hijacking yet another set of IoT devices, right? Well, why? Because it's all default username, passwords, easy to guess, SSH that is open. Like, we cannot really treat it as a server platform. Physical access is a big deal, right? Again, one of the popular attacks that is absolutely unheard of, or at least mostly unheard of in a data center, is just physical attack, right? People can try to stick random, USB sticks, or sometimes even manufactured USB sticks into these devices, right, and see what happens. Theft happens all the time, and obviously network, experience DDoS attacks and things like that. So how do we actually protect against it? Next slide, please. So we've come up with this zero trust model in Eve, which is all based on the crypto-based identification. So all of the root of trust is rooted at hardware, which makes it much more difficult to hack and exploit. We basically completely got rid of traditional usernames and passwords. So Eve is a appliance operating system. It basically doesn't have a notion of like an account or anything like that. We measure every bit of software that gets loaded onto the machine, so we use measured boot. We have a distributed firewall to protect against network threats. Obviously, everything is protected through the encryption, so TLS, every which way. For physical security, we actually invest a great deal in port isolation. So unlike your typical Linux installation, where if you boot your favorite Ubuntu or Red Hat distribution, you would basically have all of the physical, periphery just available to you and on by default. Like, again, you plug a USB stick, it just gets detected and the driver gets loaded. All of that is completely disabled and, off by default in Eve. So again, we've done a lot of just hardening and kind of like making sure that the platform is really secure by default when you deploy it out there in the open. Next slide, please. And what it gives you then, it basically gives you a remotely managed universal platform to be, so you can put it on any type of compute equipment that sort of fits into this rough profile of user edge, right? A typical box that Eve would run on would look something like this, right? It's a very ruggedized, Intel, typically Intel-based, although we support both Intel and ARM, but most of the boxes that we see are Intel-based. It's typically Intel-based, Atom, It typically has like 2 to 8 gigabytes worth of RAM. Typically 4 to 8 cores. Typically, like 20 up to 100 gigabytes worth of flash, no more than 1 terabyte. I haven't actually seen a single box with more than 1 terabyte of flash. And these boxes typically come out of manufacturers that are not really household names, right? I mean, sometimes you can buy them from like maybe Dell, but that's about it, right? The rest comes from Advantech, Lanner, Supermicro, much more known for kind of like really plumbing of a data center as opposed to being sort of IT companies like, HP and, IBM and all these other ones. So that's roughly what Eve has to run on. So now let's actually take a look into what it is. So next slide, please. So like Aaron said, Eve basically has a sweet spot, which is, this user edge. But on the user edge, we are completely staying away from microcontrollers, that leftmost part that is completely constrained, right? That is still the domain of specialized real-time operating systems. Linux Foundation, by the way, has a great one called Zephyr. So Zephyr RTOS is typically what you would deploy on the leftmost piece. The two other building blocks in the user edge, the smart device edge and the on-prem data center edge, that's exactly where Eve would go. Next slide, please. So what is Eve, right? Just very quickly, if you forget anything from this presentation, remember, the outline of the projects that Aaron gave you and this slide. So what is Eve? So it's basically, an operating system that you deploy, and then you use a controller, to tell that operating system what to do and what applications to run. So Eve OS itself is lightweight. I will tell you a little bit more about, how much overhead it has. And you would use it for all of the reasons that I described, because again, protecting the edge is pretty challenging. So Aaron, if you can skip the animation, please. I think we have some of it on this slide. Yeah. So some of the other approaches that we tried, because again, when we started the company, it was pretty clear for us what needs to be solved. But obviously, there could be different ways of solving it, and you can still see some of that in the marketplace. So one approach was, just proprietary bare metal, hypervisors, super secure systems. You see them a lot in automotive and especially military. So, Tomahawk missiles, basically have an embedded operating system that also uses a hypervisor, right? And it's all cool. The problem is that you cannot really write applications, for those types of environments with the same ease that you can write an application for, let's say, something like an Android operating system, right? It's super secure, but super difficult to program for. So that was out. Then, that's on the left, right? The rightmost approach is sort of this free-for-all. Like if the leftmost is the most constrained, the rightmost is, this free-for-all. Let's just install any operating system. Let's maybe just have like a small agent that runs on that operating system and tries to make it as secure as possible. But hey, if we miss a few things or if the operating system itself doesn't behave, what can we do? The agent will maybe recognize a few default, names like, Red Hat and Ubuntu and a couple of others. But if it cannot recognize a certain, sort of aspect of the operating system, it will just leave it be. So again, if you end up with like open port, because somebody managed to start an eBPF, plugin into Linux kernel, like agents would typically not be able to catch that, right? So we actually went with this approach right in the middle, which is on one hand hypervisor-based, sort of taking a page out of this military-industrial complex, book, right? Making the system really secure. But on the other hand, it's a hypervisor-based approach that allows you to run any kind of modern applications, virtual machines, containers, and container orchestration systems like Kubernetes. So you kind of get the best of both worlds. You get a super secure system, but your applications can be expressed as just containers or VMs. Next slide, please. So this is the money slide for Eve, right? This is the architecture slide. So Eve itself basically is a replacement for your traditional Linux operating system or even Windows. You would install it on bare metal. So the joke that we have about Eve is that even the way you install it is very sneaky, right? So the installer actually comes on a USB stick. And if you put that USB stick on a machine that already has some kind of an operating system installed on it, what the installer would do, it would basically scavenge bits and pieces of that operating system, turn it into an application, essentially a virtual machine. Basically, put that virtual machine aside, install Eve itself on bare metal, and then put that virtual machine back, but now as a virtual machine on top of Eve. A lot of times why it's cool is because a lot of times an operating system that's running on the bare metal doesn't even realize that it has been virtualized. So we've done a few cool demos where we would take just like an unsuspecting, industrial PC with Windows or like with Linux, right? We would install Eve on it, that way, and all of a sudden your operating system still comes up, and it thinks like nothing has changed, but now it's actually running on top of the hypervisor. Because Eve comes with two hypervisors by default, Zen and KVM. We're also working with Intel on the industrial-specific, real-time specific hypervisor called Acorn. And there's a few other actually be able to leverage. So Eve itself is not a hypervisor, right? Eve is a system that puts all of these bits and pieces together. And if we need to use a different hypervisor because our customers demand it, we absolutely will. Now, once you install Eve on the bare metal, Eve itself takes about half a gig worth of space, right? So that's the overhead you have to pay for Eve itself. But no more than that. Everything else is, given back to your application. And 500 megs is actually very, tiny by modern data center standards, right? A typical deployment, typical installation of Ubuntu would easily take a few gigabytes, right? So Eve is actually playing very nicely. Within that 500 megabytes, you basically get an partition A, partition B, green, black partitions, for the upgrade. So the upgrade of Eve itself is always safe. It's sort of exactly like the system that you have on your Android, where, when your AT&T or Verizon pushes the next update, Android platform would actually kind of download that update, try it out. But if anything happens, it would actually go back to the previous, firmware. It's exactly the same trick that we're playing on Eve as well. And all of it fits into 500 megabytes. Now, in terms of the CPU, we basically take away one core. So one core belongs to Eve, and we just kind of like make use of it. And we take away about 500 megabytes of RAM. So Eve is basically 500, 501. So that's the overhead you're paying. Now, on top of the hypervisor, you end up running kind of two classes of virtual machines, right? One class is all of the virtual machines that comprise Eve itself. These are the microservices that end up talking to the Eve controller to basically get commands of what needs to be instantiated, what needs to be run, what kind of networking, what kind of containers Eve needs to download. So that's sort of system level software. You could think of it that way, right? And then that's on the left. And then on the right, you basically have user, containers or VMs. And here, for example, I'm showing a configuration where Eve was instructed to download. So Eve controller, basically told Eve to download two VMs. One VM is K3s, which is a popular Kubernetes deployment platform, right? Container orchestration. So when that VM comes up, it would actually connect to Rancher Cloud. So it doesn't really have anything to do with Eve or Eve controller. It just has its own control plane, and it will connect to it, and it will do the right thing. But from the Eve standpoint, it's just a VM. And the second VM that Eve controller instructed Eve to download was Windows 10. So that just, it could be your industrial SCADA application, anything of that nature. And that's basically the steady state of Eve, right? It boots, it contacts its controller, it gets instruction from the controller, and it realizes those instructions in form of virtual machines or containers. That's it. That's kind of like very simple on one hand, but also, sort of pretty tricky to do if you want to do it right. And one last observation that I will make here is that this architecture is exactly what every single cloud company has built internally, right? Amazon, Google, Microsoft, they have all built an equivalent of Eve to automate operations of their public clouds, right? Because what I've just described here is no different whatsoever from what a typical server would do inside of Amazon's or Microsoft's data center. Because they do exactly the same thing, right? There's a hypervisor, typically Zen or KVM. The hypervisor boots. There is a control plane, that's inside of a data center. That's totally proprietary to Microsoft or AWS or any other company like that. But then all of the user workloads get expressed either as VMs or containers. So in a way, Eve is an open source version of what all of the hyperscale providers have built internally. So that's what Eve is. Next slide, please. So Eve, like I said, is consists of a lot of microservices, these system services, and I'm sure the presentation will be made available online. We actually have that same slide deck on our wiki, in Linux Foundation. So feel free to kind of so you don't have to squint, You can basically deep dive into the architecture. But the architecture of Eve is very microservices friendly in a sense that those are not kind of like web related microservices. Those are the microservices in the old Unix sense, right? They are services that basically manage one particular function on the box, and they only responsible for that. So a good example would be we use TPM, Trusted Platform Module, to basically realize the root of trust. So there is a component, there is a microservice that's responsible for talking to the TPM, and everything else that needs some kind of a TPM functionality would have to talk to that microservice. So that's how we distribute, all of the functionality throughout the system. So next slide, please. Can you skip through the animation so I don't have to, synchronize to it, just so that, it gets fully animated and the slide is complete. So like I said, basically it all starts with a controller, right? Controller has a UI. So we actually have an open source controller. It's as kind of a brother project to Eve, right? It's called Atom. It's all available in Linux Foundation. But as a company, my company, we actually make money off of the commercial controller that we have built. So that commercial controller comes with all of the bells and whistles you would expect, a modern day public cloud providers to have. There's the app marketplace, there's the web console, but other than that, it's just a controller like any other, right? And typically, the applications that get deployed on Eve, they talk to public cloud. So we have a lot of special sauce in the controller, that makes it nice to work with public cloud providers. So, we can realize networking, in a particular way and whatnot. But other than that, it's the same architecture that I just described on the previous slide. So next slide, please. So to complete this analogy with an Android, just like Android basically answered the 4 fundamental questions of how we do application sandboxing, how we do application bundling, how we do application deployment, and what hardware do we support. In the same way, Eve is answering exactly the same questions. Now, Android happened about 20 years ago. So obviously the state of the industry has changed a little bit. So we're answering those same questions a little bit differently. But these are fundamentally the questions. So the tagline for Eve is literally Eve is trying to be to the edge what Android has become for mobile, right? We're trying to be that layer that completely desegregates or disintermediates hardware people from the software people, so that the hardware people don't have to worry about device drivers and whatnot, and the software people just know that they can build a VM or a container and it would just work. So that's the goal in life. And we would like to be as ubiquitous as an Android is. So just like today, if you're building anything even remotely describable as mobile platform, right? Your first thought of what operating system to put on it is Android. Like you're not trying to build an embedded Linux, right? You just know that you can take Android and, with maybe a few tweaks, it would probably work on the platform that you're building. We're trying to get Eve to the same stage where, you can just take Eve and basically make it the default, platform that goes on every single edge computing device. So next slide, please. So zero trust, like I said, it all starts with the hardware root of trust. It's typically a TPM or some kind of a trusted execution environment. We also look into the aspect that all of the user management has to be done through the controller. So we have a pretty sophisticated RBAC and remote sort of management for devices type of applications. Distributed firewall is built right into the Eve, so you don't have to install any additional products to get that. And like I was describing, everything inside of Eve is built through this layered security model where individual microservices are firewalled away from each other. So even if you exploit one, you don't exploit the rest of the system. So to give you one example, a popular exploit in a traditional embedded Linux is to try and exploit some kind of a radio technology. So a popular one is Bluetooth, because Linux kernel is actually full of Bluetooth exploits, still. And if you exploit that, all bets are off, right? You own the box. In our case, if you exploit, the radio bit, right? That's all you have, because everything else is protected by the hypervisor. What ties it all together is that idea of a controller, because controller is the only authority in charge of telling Eve what to do. So obviously, the link between the controller and Eve has to be symmetrically authenticated. We do it through a pretty rudimentary scheme. But if you're curious about, some sort of like pretty futuristic, roadmap items, we're actually looking into applications of blockchain and trust management on the blockchain to manage the relationship between the controller and all of the Eve devices that have to be out there and sort of, get the instructions from the Eve controller. Now, if you're thinking to yourself, hey, I've seen it before, yes, you have. This is exactly how modern botnets function. So modern botnets basically establish trust, and they manage that trust through technology that is very similar to blockchain, and that's how they sort of operate the command and control. So in a way, one way to look at Eve, it's a botnet built by good guys. So, that's what Eve is. Next slide, please. So once you deploy it on the box, you basically have a very granular software-defined controls. So you can tell the box exactly what network ports to open and close. You can tell the box exactly what physical ports like USBs and sometimes GPIOs to make available or not. But you can also build pretty sophisticated network topologies between applications that are running on the box and also public clouds that these applications need to connect to. And that's actually one of the key features of Eve, right? Because we're using hypervisor, we can fake a lot of things to make it much easier for you to use them, right? So my favorite example is connecting to Amazon AWS VPC. It just so happens that Amazon VPC is implemented using strong Swan, so it's IPsec. But if you want to connect to it, there's actually a lot of documentation that you need to read because a lot of configuration needs to happen on your end before you can successfully connect to Amazon, VPC. Now, it's all doable, it's all very well documented, but an unsuspected person would typically spend like a day just trying to figure out, how to do it, and probably a day more trying to figure out how to do it reliably, and probably a day more trying to figure out how to do it securely. With Eve, because we're using a hypervisor, all you can tell Eve is like, hey, I want to connect to that VPC on Amazon, and Eve itself knows how to do it, right? All of the building blocks and for that support are built right into Eve. Your application only gets a virtualized network interface card, virtualized NIC. So all your application needs to know is that it needs to send traffic, through that particular NIC, and that's it. Like that traffic just ends up in the Amazon's VPC. That sort of looks like magic to you, but that's what is possible when you actually use a hypervisor. You can do a lot of magic on the other side of the hypervisor, and your application inside of the VM can be kept as dumb as possible. And that's actually not, kind of like a gimmick, right? We use it a lot of times for our industrial customers when the applications that go inside the VM are actually pretty old. So a lot of the industrial applications still use Windows-based applications. And when I say Windows-based, I actually mean Windows XP, believe it or not. So with Windows XP, you wouldn't even be able to install modern-day, IPsec-like solutions because, they're just not available for Windows XP anymore. In our case, we can just put that Windows XP inside of a VM and successfully run it on Eve. And that old-school Windows VM is now appearing on your VPC inside of Amazon. How cool is that? Next slide, please. Yeah, the previous one. Yep. So like I said, our controller actually has, the commercial offering. So this was, I think, one last plug that I will make for the commercial offering. So our commercial offering has a lot of bells and whistles that allow you to receive telemetry from these devices and basically analyze patterns, right? So you can analyze, let's say, a pattern of, what your applications are connecting to. You can analyze, how quickly your applications, are utilizing hardware resources, all the different kinds of telemetry that might help you do, what's typically known as predictive maintenance are available through our commercial controller. And you can also stream them into your favorite, graphing system like Kibana, anything like that. But you do get a lot of mileage out of knowing what your application is doing. And again, all of that is only possible because we control everything that has to do with interface between the application and the hardware. The hypervisor is that layer that allows us to capture and intercept all of the attempts of the application, and the virtual machine to interface with the hardware. So that's brought to you by the hypervisor. So next slide, please. So what we are trying to build is, an operating system, but it typically has to go on some kind of a device. So this is an example device, that we've built for one of our POCs. I believe it's manufactured by a company called Lanner. And typically, Lanner would offer you a choice of Windows or Linux, that would go on that device. We installed Eve, that went out without a hitch. And then, it was basically an experience that we gave to our customer. And an interesting quote that, I received from that, because the customer was pretty sophisticated. They basically looked at it and said, like, hey, this looks a lot like, this operating system that Edward Snowden trusts called Cubes. And that's exactly right. I mean, Eve is probably, if you're looking for, similarities in the open source community, especially, the only one that comes close would be Cubes OS. That indeed is the only operating system that, Edward Snowden trusts. And it's also built with this idea in mind that everything needs to be expressed as a VM, and all of the disaggregation between VMs and protection needs to be done by the hypervisor. So if you would like to have kind of like an Eve equivalent running on your desktop, I actually highly recommend that you check out Cubes. It's a very interesting Linux-based operating system. It's actually kind of fun to run. Next slide, please. So yeah, I mean, securing the edge of the network is kind of difficult, but with us, you get the TLS protection, you get intruder malware protection, from all of these insights that controller gives you. And essentially, everything gets to be rooted at the hardware. So even at the network level, if you want two of these boxes to talk to each other, we give you the default overlay network, where the IPv6 addresses of every entity that exists on that overlay network is basically a crypto hash of a public key of that entity. So you're effectively routing to a public key. And how the magic of routing happens, again, that's our business. But you always know that your traffic is encrypted to a certain key, and it actually gets even routed to that same key. So that's actually pretty cool. Next slide, please. We do secure software updates. Like I said, we put a lot of thought into making sure that Eve never breaks. So Eve software itself needs to be updated, just like you would update your VM, running on Eve. Sometimes you need to update Eve. This is done a lot, like your Android. And we're basically trying to make sure that every component on the box, including the firmware and the BIOS, can be upgraded in the safe manner. So Eve is, like I'm saying, it's a lot of the same bits and pieces that every big hypervisor, not hypervisor, but hyperscaler company have built for their own data centers. So Eve is giving you a lot of that manageability back. Now, you could say like, well, but I get a lot of it from, let's say HP's ILO, right? Dell has this certain, same technology. It's basically kind of like this side channel into your server that you would use to basically manage it. That is true, you do. But none of it is available on the edge because it typically requires a dedicated network. It actually requires a much more expensive hardware. Eve just runs on bare metal boxes, and we are not really even requiring, anything like, let's say, ME, Intel's management engine, right? So we sort of expect the box to be kind of a quality and, capabilities of Raspberry Pi, and we can actually protect that box pretty successfully. So in that sense, Eve is kind of proof to the trend that existed in a data center for a long time that we actually probably shouldn't be making our hardware too smart. All of the smarts should be put into software because software is actually much easier to upgrade. And the more smarts you put into the hardware, the more you end up hostage of situations like what happened with Intel and Spectre and Meltdown, where, it's like the hardware is smart, but when it gets owned, it really gets owned, right? Because like it's actually very difficult to patch it. So Eve is, the other approach where it's like, yeah, let's just get out of the, putting everything into the hardware game and just focus on the software. So next slide, please.
Hey, actually, Roman, we had a question that kind of ties into this. So you talked so much about the hypervisor and how great it is and how you can do it. But what are the downsides of using a hypervisor?
I think the only downside is that if you want to get a reasonable performance out of the hypervisor, you have to use a reasonably recent CPU. All of the CPUs in the Intel and ARM family now have hypervisor related extensions. And it's actually nowadays pretty difficult to buy an Intel CPU, even in an SoC fashion, that it doesn't have hypervisor extension. So Intel is actually fine. On ARM is still very much fragmented. So it is pretty common to get ARM SoCs that don't have hypervisor extensions built in. And then you're kind of stuck, right? You cannot run a hypervisor on a platform that doesn't have hypervisor extensions. So it sort of limits your reach. But I think kind of I would expect, a similar trend to happen with the edge that happened with Android, right? Because Android actually drove a lot of thinking and design behind, CPUs like Snapdragon, and it sort of like became synonymous with Android, right? It's like what's inside your cell phone is determined in a lot of ways, by the Android. And it doesn't mean that ARM doesn't produce other types of SoCs, right? And they're useful, they get used, for real-time operating systems. But the mobile platform itself has become synonymous with just a few, selected ones. It's a subset of the generic ARM ecosystem. So I would expect the same to happen, with the edge computing as well. But the biggest downside is if you have hardware that doesn't have hypervisor extensions, you're kind of stuck.
All right.
So like I said, we actually do a lot of the work to give you security from the cloud by default. So we work, by the mechanism that I just described to connect you to public cloud VPCs, to basically make you part of the VPNs of various kinds. So again, all of the default connectivity that you would expect today, because everybody is on the public cloud, right? There's not a company that wouldn't be on the public cloud. So we very much recognize that edge is an extension of the public cloud. It's not a separate set of assets that you have to manage. Your public cloud and your edge assets have to work in perfect harmony. So all of the security issues and policy-based controls that you would typically apply to your, let's say, Terraform profiles, to realize certain architectures in AWS, all of that applicable to Eve as well. So next slide, please. So yeah, just to give you a few Eve customer examples, and I think we'll pause there because we're sort of running out of time. We have a lot of customers in oil and gas, some in healthcare, a lot in energy, and a lot of manufacturing. So all of these, can be described as critical infrastructure, right? We're actually now starting to get a lot of customers in the retail as well, but this is a bit of a new trend. And even retail, a lot of times can be described as critical infrastructure, because a lot of times you use, the type of compute equipment that I described to do, surveillance and video analytics, and it's, a lot of times sort of crosses over into safety of your retail location. So even that becomes a critical infrastructure. So the reason I'm pinpointing or highlighting the fact that all of these verticals actually happen to be critical infrastructure is because there is a lot of government efforts right now to kind of come up with a common joint, definition of what that common infrastructure needs to be in order to be secure, but also flexible. And I cannot really go into many details, but Linux Foundation has some exciting announcement, coming out in February timeframe that you all should really watch out for when it comes to unifying various, disjoint efforts around, making critical infrastructure reliable and secure. So keep an eye on it. Eve will definitely play a role in that. But I think, an overall announcement that will come out will be very, very exciting. So with that, I will pause and just kind of like let, the questions roll, or, we can talk about different customers, what have you.
All right. So, Rex, if you want to come on stage, if you could raise your hand. Otherwise, he had another question. Have you looked at Parsec project?
Yes, we very much looked at Parsec. Parsec is a very useful library that came out of ARM, efforts. That basically would be an ideal building block for Eve to unify various types of TPM-T environments. It is not something that we would probably expose to our customers, but it would be something that makes Eve's life internally much easier, right? So I'm super happy about efforts like Parsec, because it is sort of this effort of providing useful building blocks for the rest of the open source ecosystem to build solutions like Eve. Because again, remember, Eve is not a building block. Eve is in a lot of ways an integration play. It's just like your favorite Linux distribution, Ubuntu or Red Hat, is not really a building block. It is integration of other building blocks. Even the same way is integration of building blocks, and we would love to have Parsec as one of the building blocks that comes into Eve.
Cool. All right, that makes sense. Folks, if you have questions, raise your hand, or you can ask it in the question, and I'll bring you onto the stage. So I had a question. So based on what you guys are seeing in terms of Eve deployments, what's the ratio of brownfield versus greenfield? Since you support industrial PCs, like what are you seeing there?
Up until this point, I would say it's about 60-40. So 60% is greenfield and 40% is brownfield.
Yeah.
On the company side, on the ZDD side, we actually also have some exciting announcement that is expected to hit next week. So again, watch that space. So you will see a major industrial company announcing that they have invested in us. And with that investment coming in, I would expect the ratio to flip because they're definitely very interested in bringing Eve to all of their legacy deployments.
Okay, perfect. It looks like, well, we just had comments. So Kia says fantastic product and presentation.
Thank you so much.
Hang on. I have one person. Okay.
Hey guys, thanks for the presentation.
Here, Andy.
So
Go for it.
If you're drop shipping from a factory to a customer, how is it that you know what the keys are in the TPM from the factory to know what you should accept in your cloud? If that makes any sense.
Oh, it totally does. And we're actually working with Intel on the initiative that they have, for managing the kind of supply chain, and how the keys traverse the supply chain. I actually don't remember if that project is already part of the Linux Foundation or not. Actually, Aaron, do you know if Intel's what's it called? Yeah. Is it part of Linux Foundation yet or not? Do you know?
Yes, it is. It's part of. It's a level 1 under LFEdge.
Okay, so there you go.
So it's one of our sister projects.
Yes.
Sorry, what was it called, please?
SDO, Secure Device Onboarding. And they are really in the process of spinning up their community. So there's a little bit of information out there, but it's I have a feeling with COVID, or everybody's excuse is COVID over the last year. But yeah, they are starting up, and they're starting to spin it up.
So I mean, we're actually very excited about it. To answer your question, so I would expect SDO to be our preferred solution. But again, if anything else comes up, from let's say ARM side, we would also be interested. But for now, Intel seems to be ahead of the game when it comes to managing keys through the supply chain.
Cool. All right. Any other questions?
Well, here I'd like to follow up a little bit with that, because one of the I'll ask this as a question. So, as he said with the kind of the drop shipment, can you kind of expand a little bit on that? Because one of the biggest problems in IoT for this type of management is how do you, if you have to install 1,000 boxes, I mean, are you supposed to ship 1,000 boxes to your office and then ship those out, or basically how does Eve make that easier?
Yeah, no, I mean, that's a great question. So our preferred model is to basically make sure that anytime you order from a Asian manufacturer of hardware, you basically get Eve as one of the default options that is just available. Because today, Linux of various flavors is that option, typically like a non-commercial Linux like Debian. So you can basically go to any factory in China, to be super specific, and ask them to build a box for you to a spec. And when they ask you what operating system to put on it, there's basically a few that they can do very easily, and Debian is typically one of them, right? And then if you need anything special, anything custom, you have to pay extra. Like it's complicated. So we want that list to include Eve. So that's the default answer, right? We want like every factory in China to be able to add Eve to that list and say like, hey, Mr. Customer, what do you want? Like you want a traditional Linux, we can put Debian on it. You want this sort of next generation edge computing platform, we can put Eve on it, right? We want that. So once that happens, then the question of like how the box at that point, traverses the supply chain is only interesting in the SDO context, because then you kind of need to keep track of keys and what gets to be put into TPM at the factory, how do you actually manage it and all that. But the operating system itself doesn't change, right? You turn the box on either in the lab or at the deployment site, and it's still the same Eve. It just connects to the same controller, and it can authenticate itself using the key that you trust. That's all there is to it.
Cool. All right. Another question from Rex. Have you looked at OpenFaaS?
Yeah, that whole aspect of serverless at the edge, I think that's actually where the puck is going, right? The puck is definitely not there yet. And I would expect it to really arrive in 3 years, if you were to like ask me to place a bet. But this is for sure where the puck is going. So at the end of the day, like I was showing on my slide, Eve today is in business of, two things, right? Thing number one, deploying your legacy applications, and that's typically Windows. A lot of times, some older Linux, but typically Windows. But that's not forward-looking, right? We actually expect those applications to kind of ramp down. So then the next question is like, okay, if that is ramping down, what is ramping up? And today, a more typical traditional, container management is what's replacing a lot of functionality of that, Windows VM, right? So that's why I was showing that a customer would typically deploy that Windows next to something like K3S, and then try to kind of like squeeze functionality out of the Windows VM and make it all, container-based and modern looking, right? And run it on the same box. So now you need two VMs. But I think the ultimate, endpoint on that customer journey is to be able to run yet another VM that basically hosts something like OpenFaaS, which I'm, really familiar with, and allows you to do a lot of what is known today as serverless, right? Now, the relationship between the container and FaaS is to be determined. So you can kind of like run it in the same VM that you're running K3S, so you can run it some side by side. We're still, experimenting with it, but our kind of like, just to prove that we're serious about it, I can tell you this much. So a lot of the, my company, Zedida, actually has 4 co-founders. I'm one of the co-founders. And 2 of the co-founders, myself included, we came from the background of experimenting and building a lot of cool prototypes with unikernals. And we expect unikernals to be enablement technology for actually making serverless really effective and really efficient. And because Eve is hypervisor-based, serverless through unikernels based on a hypervisor, to me, that is a winning combination.
Perfect. And it looks like he had a follow. He's also asking about Greengrass.
Yeah, Greengrass becomes just like a K3S, right? It's just a runtime, that you would deploy. It would talk to its own control plane. It's yet another runtime. Like we don't actually have a commercial agreement with Amazon because I don't know if you have noticed, but it's pretty difficult to partner with Amazon. Like they tend to do a lot of things themselves. But we actually have a formal commercial agreement with Microsoft. So Microsoft has a moral equivalent of Greengrass. It's called Azure IoT Edge. In a lot of ways, it's actually more superior to Greengrass, in my opinion. And we actually have an agreement with Microsoft where we deploy Azure IoT Edge on top of Eve, so that Microsoft doesn't have to worry about all of the hardware issues. So if you go to Microsoft Azure Marketplace and you search for Zedida, you will find the solution there, and you can actually see a short video. That video, if you replace Azure IoT Edge with Greengrass, that would be an answer to the question.
Okay. 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 He has another question. So I can't bring you on stage because unfortunately, he's babysitting.
Oh,
so
okay.
he's got another question. I have been watching the space of cluster development. Are you seeing an increase in customers building edge clusters orchestrated with Kubernetes?
This is actually such a perfectly timed question. It's so awesome. And if I can find it, let me actually find it, because I was discussing this, very lovely subject on Twitter the other day, because there was a report that came out of SysDig that basically analyzed a lot of usage of Kubernetes, and not just on the edge, but edge was definitely included, right? So let me see if I can actually find it. Just give me a second. But basically, quite interestingly, what that report is saying is that unlike what we would all expect, most of the Kubernetes clusters are actually small, so they're smaller than 10 nodes, and even more unexpectedly, they're actually pretty short-lived.
Oh.
So this is actually perfect news for Eve, because Eve is exactly in that game. Eve is basically in the game of making sure, oh yeah, here it is. So let me paste it here. I guess I can just paste it in the chat window, right?
Yeah.
So click on this link. Fintan, pretty good friend of mine, is analyzing that report in great details. But some of the points from that report are really salient, right? And I feel like, this idea of Kubernetes cluster to rule them all is panning out, but it's panning out in a very unusual direction. Kubernetes, in a way, becomes a very easy way to manage your containers, but it's not like you are doing it in a one unified, humongous cluster. It's like you're basically spinning up those Kubernetes clusters all the time on demand. And this is actually great because that's what Rancher wanted with K3s. That's we want with Eve. So like we're actually welcoming this direction very much. But yeah, do go through that SysDig report. It has a lot of nuggets that are really worth looking into.
Awesome. Any other questions, folks? Oh, it looks like Aaron's going to share the report.
Yep.
Okay. Yeah. It looks like that was the last of the questions. Roman, thank you so much. This actually takes me back to my VMware days.
Yeah, absolutely. I know. We had that conversation. Yep.
It's like deja vu. And only on small.
It is. Well, but no. But that's the deal. The size of the thing is exactly the same as we had in like 2000, 2005, right? So it is VMware all over the game again, right? It's the same 8 gigs. Like that's what we had in our data centers,
Yeah. No, I mean it's good. It's good, right? Because you're leveraging existing skills as well, right? There's no new thing, so it's very good. Oh, it looks like Rex just made a comment. I feel like clusters are taking off. Something about the economics of mass market boards and clustering them versus big, heavy devices. Small, high volume clustering has some good kind of tipping point. IMO per dollar.
But yeah, I think one issue, and again, it would sound like a plug. I don't mean it like a plug. I just mean it like sharing my experience. One issue that prevents clustering on the edge is the fact that networking is completely screwed up, right? All of these devices are behind multiple sets of net boxes. They kind of like your Android phone, right? Like 1 minute they're connected on Wi-Fi, the other minute they're connected on LTE, right? It's like it's very difficult to do reliable networking on the edge. So if you want to do clustering, these nodes actually have to have a way to find each other, right? And now comes the plug part. With Eve, we just give you the mesh, overlay networking right out of the box. You don't even have to do anything special. Like it's just there. One K3s node can talk to another K3s node, regardless of how many net boxes are between them. If you're just trying to deploy, Kubernetes or K3s by itself on a Linux system, right? Well, then you have to build all of it yourself, because it clearly is the case that just sending an IP packet to what you think is an IP address of that other node will not work.
Okay. Cool. He has another comment. The economics have changed. $25 Pi module might have hit some tipping point.
Oh, yeah, I agree.
Randy, I
agree. Yeah. In fact, Aaron, I'll just plug your work on the Pi and Eve. So if you can share that link, that would be awesome.
I'll find it real quick. But yes, we got Windows 10 due to the hard work of Roman and some of our other colleagues. Now you can run Windows 10 on Raspberry Pi, and it works.
Oh, wow.
It's quite cool to watch. But yeah, give me a second to find it.
In the meantime, Randy had a question.
Yeah, so I'm super excited to try it out. What's the best way to get started with Eve? Is there a Hello World tutorial?
Yeah, absolutely. So we basically have like any self-respecting open source project, we basically have a GitHub page, right? So I'll just post it, here. So there's a lot of information available there. But if you want to play with it, I actually recommend the companion project called Eden. Here it is. It's all part of the LF-Edge. And Eden basically comes with a pretty detailed tutorial on various types of deployments you can actually do with Eve, right? You can run Eve on your laptop. We actually allow that. It's fine. You can run Eve on Raspberry Pi. So that tutorial that I just posted on the Eden side has all the steps that would be required to run Eve on the Raspberry Pi. You can run it on GCP, Google Compute Platform. You can run it on Packet.net. So, the sky is the limit at this point. What I would highly recommend is joining our Slack channel, because, there's a lot of good people who can help you if you get stuck. And, again, it's an open source project, so documentation is still a little bit lacking. but we are super welcoming community. So just jump in and ask questions, and we'll try to help as much as we can.
Fantastic, thank you.
Yeah, and I will say, oddly enough, if this little bit.ly that we created for just this fun little screen grab, that actually dropped you in the middle of our wiki too. So from there you can poke around and get the how to get to our Slack channel, GitHub, and whatnot. But
Cool.
actually, and it's lf/eve. So
Windows runs on it. Can you do anything?
Yeah, I mean, you basically the console and
you run Windows.
Right. So can you do anything?
What do you do with Windows? You play solitaire, of course. I mean, that's what you do with Windows.
All right. Well, then awesome. I'll go sign up now.
Well, I mean, the main limitation at the moment is that you have to go through remote desktop into it is the best way. Because Eve is still running on your monitor, so you can't just plug in a keyboard and a mouse into the Pi. That's the only limitation at the moment. And we kind of talk about it in here, and I have an article that's coming out real quick. That's about it. But here is Eve, and then down here is how the shortcuts to everything. So it's just lfedge.org, and then from that you can see everything there. And it works really well. And we also had some stuff, because I see some people from NVIDIA. I think it also works on a Jetson. I think we got somebody to do it, but I'm not quite sure if we have that written as a tutorial yet. So.
And if we still have maybe 2 or 3 minutes, I can actually show you how easy it is to deploy Eve on packet.net. So if you can allow me to share my screen. Yeah, let me see if I can do that. Maybe. Okay, my entire screen, yes.
So as you can tell, as you figured, it's open source. People are geeks that hey, look at the cool stuff we did.
Yeah, pretty much. Pretty much. Yeah.
I mean, we'll go forever if you want. So, up until family comes in and says, "Hey, wait a minute, what are you doing?" But I have a feeling that's common.
Okay, can you guys see my screen?
It's coming up.
There you go.
Awesome. So Packet.net, that was recently bought by Equinix, is actually my favorite way of kind of playing with a lot of hardware that I don't have to keep in my lab. It's just basically they maintain a bunch of data centers all over the world, and they give you different types of hardware, Intel, ARM based, what have you, to play with. And the good news is that it's all API driven, right? So if I want to deploy something new, I basically just click here, right? And let's pick a random data center, and in that data center I have all these different awesome hardware types, right? So there's really cheap Intel, there's much more expensive ARM based KVM, Thunder X, a lot of cool stuff to play with, right? So let's pick the most inexpensive Intel, and you can actually deploy existing kind of traditional operating systems. You can even deploy VMware ESX, if you have a license for that, or you can deploy Eve. And in order to deploy Eve, all you have to do is click this custom iPXE. So Eve is, like any self-respecting operating system from the 80s, comes with the network boot, network installer. So if you go to our GitHub, and you go to one of our releases, right? Let's say this one, you will see the artifacts that are expected to be there, when you do a network boot. And all you have to do is just take this link, copy link address, provide this link as a custom iPXE script URL here, right? Click this deploy button, and you will have Eve running on your Packet bare metal host in no time at all.
Cool. All right. It looks like that was the last of the questions. Thank you, Roman. Thank you, Aaron.
Oh, my pleasure.
Yeah, my pleasure.
Aaron, this is awesome. It looks like we have at least one person who's going to sign up. If you guys have questions, I don't know, Aaron, are you going to hang out? Roman? Yeah. So as soon as I hit the end button, end section, it will take everyone to the lounge. If you still have questions, there is a Project Eve table set up. It will take up to 8 if it gets up to 8 and we need to set up 2 tables. I can set another one up, or just go on to another table. Otherwise, thank you everyone for coming out, and thank you guys for sharing this. This is really good. I am so excited. This is the best thing about doing these open source meetups is realizing how far things have come in open source.
Oh yeah.
It's amazing.
Yes.
And even just looking at the community, right? If you look at LF Edge and any of the others, and who is behind and supporting them and contributing, it's awesome.
Yep.
So it's just like it changed cloud, it's going to change IoT too.
Hopefully. Well, and thanks for having us.
Yeah. All right. So I'm going to end the session, and I'll see you guys in the lounge.
Okay. Bye bye.
Thank you, everyone.